Hello, and it's Monday night, and it's time for another Let's Make It. But is it 9 o'clock? Well, it's 9 o'clock somewhere, I'm sure, because there's 9 o'clock somewhere. I am recording this a couple hours early, only because I can't be in the studio at 9 o'clock. I can be on the chat room, no problem, and I'll be in the chat room with you to talk, answer questions, things like that. But this is really a replay that's playing at 9 o'clock, so I can't answer your questions live, unfortunately. So, but you can see, look where I am. I'm back in the studio. Not quite 100%. If you go to the drop cam and look, you can see it's close to getting back to normal. But this may actually be the new normal because I've been doing another show on the green screen, and it's that way. I started doing that whenever the was messed up in here, and people liked it. So I might just keep doing that. Who knows? This show may be coming on a green screen soon too. It's because people really liked how it looked. So, but anyway, this week I'm going to cover the Arduino Galileo. I mentioned last week we were going to talk about it because when we first got it, we just did some basic things with it, but we've been using it a lot more, and we're still finding little things here and there. In fact, we got a problem right now I'm trying to work out. And I can go through, I think, why a lot of these things are happening. I can explain a little bit more about the board now that I've used it for a while. And I can show you some of the pitfalls with it. But if you can deal with the pitfalls, it actually is a pretty nice board. It has a lot more power than what a typical Arduino does. The thing is, it runs on top of Unix, so it has to boot Unix, and we'll go through all that stuff here in a little bit, and we'll show you the process. But let's take a look at the board real quick. Let's see my overhead. There it is. So this is it right here. This actually is running right now. You can't really see it's doing anything because there's not really a sketch in it. We're going to talk about that in a second. But it does require power to run. It does not run off of USB power, so you have to plug it in. But it has a built-in Ethernet right here. It has two USB, a host and a client USB. This is a serial port, although it looks like it is you plug in your headphones there, but it's not what it is. So it overall has all the features you get in most Arduinos and more. So you don't have any additional shields. I mean, it'll take shields, obviously, because that thing's plugged in here. And but it looks like it's the same shield layout as an Uno or a I can't think of the name, but the other was small one like the Uno. So it has the same layout. It can do either 3 or 5 volt right here. So jumper, it says I want to do 3 volt or 5 volts for the shields and everything. It comes with 5 volt, at least mine came with 5 volt, and that's probably where I'd keep it because most of the shields that work with the Uno were 5 volts. So I just leave it there. There's also another jumper up here. You can change the I2C address, which I'm going to talk about because that's something that's a little different than most boards. And we discussed that because it actually has some things on here that you have to account for when you do your own development work. And also you'll see right here, there is a mini SD card. In fact, I have a mini SD card for this one sitting right here. And I'm going to say you have to have a mini SD card. If you don't, and I'm going to just show this to you in a minute, when you turn this off, whatever sketch you upload to it is gone. So if you want to save your sketch so it's there when it comes back on, you have to have an SD card. There is no other option. So I'm going to show that to you. I'm actually going to upload the Blink. I have the Blink sketch loaded here. Let me kind of get out to where, there it is. I'm going to upload Blink. So it's compiling right now. The other thing is it takes a little longer to compile. I don't know why that is, but it may just be a Mac thing. It uploads a lot faster. Okay, so there's Blink. And you can see this is pin 13 right here. The LED is for pin 13. And then you see my bright blue light over here. I have it wired backward of 13 on 13 just to show that it's actually blinking. So what I'm going to do is I can reset the sketch. There's a reset button right here, reset the sketch. And it will remember the sketch, just resetting the sketch. But if I reset the whole board, this is going to take a while, just so you know. I'm going to bring it up on my screen here and watch it, and I'll tell you how long it takes to reboot. I'm actually going to time it. Let me get a different place on my watch here where I can time it. All right, I'm ready to go. So I'm going to pull the power, just like that. And I'm going to plug it in. What time is it? It is 45 seconds. All right, we're going to time it now. See how long it takes it to start blinking. Now I can see what it's doing in front of me. I'm going to show you some other things that this board has on it. But right now we're just considering I'm going to stare at this. Staring at something doesn't make it so it never wants to boot. and it's still booting in 8 seconds. So it has it's telling me on the screen it's automatically going to start something in 3 seconds, 2 seconds, 1 second. So it's still going. There's a game show. But it's still booting. Still booting. And if I'm going to show you what I'm looking at, and you're going to see, basically it's a Unix boot. So if you ever watch Unix boot, it's going to seem very, very familiar to you. It does boot a little bit faster if you have the SD card in it. Okay, or it's up. So that took literally 57 seconds for it to boot. Now you can't tell it's booted because look, it's not blinking. Do you know why? Because I said before, I have no SD card in there. So even though that it's running, if I could come over here right now, I'm going to hit the upload button. There's upload, and it's compiling, and it's uploading. There you go. So it booted, but did not remember the sketch. So that's something very important to remember. That actually can be a very frustrating thing because you forget to put the card in. So what I'm going to do is I'm going to unplug it and put the card back in. So let me go back over here. Oh, too many buttons. Too many buttons. Here we go. All right, so I'm going to unplug the power. Plug it back in. Now, I think I have the blink sketch already loaded, but I'm going to load it anyways here in a second. So we're now going through the whole boot cycle, and we're going to stare at this blank doing nothing board. You will see up top here shortly that the USB light will come on after it gets through that part there. There it goes. As it gets through that part of the code. So one of the things I did with this boot card is I took the wait time for boot down to 0. So basically it immediately starts to boot instead of waiting for 10 seconds or whatever it is by default without the card. So we should be like 10 seconds faster at a minimum than the other one. Looks like we're almost there. There, we're done. You see the blink. So I had blink running before. So this time I remembered blink was there because I put my card in. So let's hop over to the computer real quick. And what you see here is CoolTerm. And I have this plugged in via the serial port on the board. And you see right here the login. So like I said, it's Unix. I'm going to power it off and we're going to watch it boot one more time. You can see that it does do something. It takes that long for it to boot. So let me power it off. And power it back on. And there we go. This is what I was looking at before. And when you see that login prompt, it's working at that point. It's ready to go. So when you get to that login, you know that it's up. And it goes by very, very fast. I'm not quite sure how fast it's going by to you because it's going by so fast. I'm not sure that the remote control software will actually keep up with it. All right, removable media. Yeah, you're pretty close. Starting connection manager. We're in the last step. There we go. We're logged in. So the board's back up and working now. Now, you can log in using the serial port with just using root like you would in Unix. The thing is, there is no password. So you are basically in. There's very few things running. It's a very limited command set. You can basically see right here at the bottom, the opt stuff, that's what's running. Your sketch is actually running as an executable. And then you'll see the login for the terminal. The serial output of this is at 115200. So you got to plug it in. And let me show you a little bit about how I got the serial port hooked up so we can go back over to here. And so you can buy a cable off Amazon, which I have ordered one, but it hasn't come. It's coming from China. But I'll put the link to that in the show notes. But basically, I took an old mic cable, which this is an old mic cable right here. You can barely see it. Microphone cable that was bad. Cut the end off. Put a 1.5 inch. I'm sorry. 3.5 millimeter plug, like you use like on your iPod and stuff like that. End on it, and then on the other end I put a 9-pin connector, and I didn't have the right gender, so I actually used another cable right here, which is basically changing the gender for me to straight through. Or it's not straight through, it's a problem. And then to put in the null modem adapter on. So yeah, I kind of rigged it together. And I'm going into Mac using a USB to serial. You can buy these already ready to go off of Amazon. I'll put the link in the show notes. But it's pretty easy to make it if you have a soldering iron. And I'll put also the pinouts that go make this cable in there on the show notes as well, so that you can make your own cable if you want to. And I didn't have the female end for the serial, so I had to use a male. And then this cable was a female to female, and then but it was a null modem cable, female to female, so I had to put another null modem adapter. So anyways, it's a little jury-rigged, but it works. So there's another way you can get to, there's a couple ways you can get to the command line if you want on these boards too. If you're running not off of the memory card, one way is you can use telnet. Basically, you write a little sketch that activates telnet. So it's real easy to do. I'll put that in the show notes too, how you can do it. But that only works when you run your sketch, and you got to know the IP address of your board, which we don't know that yet either. I'm going to show you how you can get that as well. However, if you download the code and make the SD card, which is actually really simple, it only has to be formatted as a FAT32 or FAT16 off a Windows box. You format it like any little card. You drag 4 files in a small folder over to it. You stick it in here. It takes about an extra 10 seconds to boot, and then it's up and running, and it's going to work. Remember all your stuff. So it's not too difficult to do, and you need to do that because if you want to save your sketches, it also boots faster with the card on there because you can change some things in the boot cycle. Well, I'm familiar with Unix pretty well, so I went in and took away the countdown and made it to 0 seconds. Things like that. I just did little things like that. The other thing is that when you put the card in, you're not going to have SSH running, so you can SSH to the box as well. The big caveat to that, and I'm going to show that to you here in a second. Actually, let me go over and show it to you. So here we are on the computer. Let me bring up a window. Well, first of all, I need to know what my IP address is. So all you do in the command line right here is you type ifconfig, and it'll give you the IP address. So in my case, the IP address is 10.232.1.124. So I'm going over here, and I'm going to SSH. And you may be using PuTTY or something like that. It's going to work exactly the same other than I'm doing it from a command line on a Mac. I'm going to log in as root, and the IP address is 10.232.1.124. And look at that. I am in with no password. So here is a huge warning if you're planning on putting something like this on a network that's public or on the internet, is you make sure you have to set your password and everything. Actually, I think you can do that. I've never tried doing that. I can. So make sure you set a password. Get out of there. All right. Because by default, if it's on the network and somebody scans your network and sees 22 and they type in root, it doesn't matter what password, because they're never going to be asked for a password. You'll be on your box, and they could start doing things like that, which now you see over here on this other window over here that it's starting to reboot. I rebooted without a password. So there is a huge issue with security if you're running off an SD card. So definitely make sure you go in and change your password. Whether you can do it from the serial interface right here where it's booting into, or you can SSH to it and do it here. Because if you don't, your box is open. And here's the thing. This is really Unix. So it has Python on it. You can install things on it. It's a lot more limited, but there's lots of good hacker tools that don't take much to run. And it would be hard for somebody to come in here and start owning the box and then they'd be able to pivot from it. So it's just a really strong word of warning from a security guy, because this little card can be a pretty major problem there. So I've shown you how to get the IP address. I've shown you how you can SSH into it using any client, including PuTTY on Windows. I just did it from a command line because I'm comfortable in the command line environment. But you can just plug in your serial cable as well and just log in as root. Oh, not as a password. But the password is blank. So, but it did ask me that time for a password. So that's the basics of getting around the board. But let's talk a little bit about what's on the board. So let's come back over here. On this board, to get the Ethernet and this card and everything, there are some other chips, as well as this CPU itself doesn't have as many I/O pins as what the the chip does that runs the Arduinos. So what they have done is they have put in additional little boards, you see them sitting around on here, that are communicated to via I2C. Now, we've covered I2C in the past. It's basically a serial protocol that allows you to have multiple devices on one bus. So these chips that emulate what the Arduino does that on these pins aren't part of the CPU, which means they're part of an I2C bus. So if you're using I2C for like an LCD display or some other kind of LCD or LED driver or button inputs, then you have to consider and take into consideration what their addressing is on this board, because you can conflict with them. So what they've done is they've given the option to have two different addresses. That's what this jumper does. So if you find that it conflicts, what you can do is change this jumper, and it'll change the addresses into an area where it might not conflict. If it does conflict in both cases, you got to make changes to your solution to make it work with this. There's no other option in this board other than those two addresses. So I use a lot of I2C now. I mean, a lot of it. And this does not conflict with anything that I have. It's in a kind of a unique range. It's pretty close in some things, but it has not hit anything yet on our boards. And I don't think that it will. We did a new breakout board. It's the size of this that it supports 4 different I2C buses off of this one CPU. And so far, we've not had any collision or any addressing issues. And I think the fact that we are now muxing our I2C helps separate that. But if you're just doing basic I2C, which I do some basic stuff with this too, then you need to consider the I2C addresses. And it's documented in the literature, and I'll point that out in the show notes as well, because that's definitely a caveat if you're already playing with I2C. There's also a JTAG header here if you're doing the debugging. I never really use JTAG. And then there's your standard ICSP, which is what's being used for this Ethernet. The Ethernet is really a W5100, just like most Ethernet shields are. So your sketches can pretty much carry over as they are. Now, I say that with some caution because that is not the case everywhere, and I'm going to show you some cases where that is not the case, and it's come back, and it took a lot of figuring out on our part to figure out some problems. In fact, we're still having a little bit of problem with some UDP occasionally that we can't quite figure out, and it's a little bit frustrating. So, but what I want to do is I want to go show you some code and things that have to change, because this is not an AVR chip anymore. This is actually an Intel chip, and there's some things that are different about it. It has a lot more memory in it. And one of the tricks that you did with the AVR to save memory is you put variables in program space, but you can't do that with this one. It doesn't work like that. So I want to go over to the computer and show you what I'm talking about. So let me get out of this. I'm just going to hide it here. And I'm going to bring up, let's bring up Text Wrangler first. Just show, it's good. All right, so here is the original web server file we've gone through in the past. And I'm going to go scrolling down through here and see if I can find out, see where it's going to cause a problem. And I'll show you what we had to do to make it work as well. Okay, hardware serial. Okay, so right here you see this prog_uchar. So that basically says this variable is in program space and it's an unsigned character. Well, that doesn't work in this particular board because prog memory does not exist. So what you have to do, I'll show you what we did through this. We went through and we did get this to work because we did use this a lot, and it was pretty important that we either rewrote one or just modified this one. And we modified this one. I need to put it out there in public so other people can use it as well. I haven't done that yet. That is on my list of things. So it's going down here a little bit farther. Here you see another one, prog_char, prog_uchar. So all of this prog_ stuff needs to be made into non-program space memory. It's a long process and a lot of testing to get it to work, but it wasn't actually too bad. It was better than what I thought it was going to be. I was almost thinking like giving up on it because you can actually load a web server on the board and Unix side of the board itself because it has Python on it and things like that as well. And So let's see, anything else in here? So let's go look at this is what we did to modify. You go and look at this. This is our web server for the Galileo, hence the G on the end of the web server. So you come down here and you see we left, actually, we commented out the print P stuff for the most part. But you come down here and you see here's char. So there's no prog_char anymore, but we got rid of all that stuff that's program related. The other thing is, this is our Wirecast header for the AVR chips, which is the typical Arduino chips. This AVR program space cannot be there anymore. So throughout this, we put things into program space. So we need this include file so that we have all our variables set and everything to do that. That has to be taken out. And anywhere you use any of that programming, the program, even the F, you put the F in brackets. I can't know if I can find one real quick, but you put F in brackets, you put in quotes what you want to be basically from the program space, and it puts it in program space when you compile it. None of that works anymore. You have to go through and get rid of all that stuff. So it is a little bit of work to go through and clean all this up. Now let's go over. I have another thing open. I have Code Runner open too for some C stuff. Let's see. This is the two different versions of our Wirecast. So let's see if we can find something in here that gives you an example. See, there's print line. Okay, so right here's an F. So you see this F right here? This is the AVR code, where you put F and in parentheses, you put in quotes, you put what you want to print, but it puts it in program space when it compiles. That is no longer an option. If you go over here and look at the same Wirecast file, that's now not there anymore. So that's the kind of thing you need to go through and you need to clean up if you have things that use this. So it's a little bit of a pain to get switched over. It depends on if you use those kind of features and things like that. So that's something you have to kind of consider when you're developing. You just can't take your sketch, or most of the time you can't take the exact sketch and move it over. Things like Blink that are really simple like that, they'll work just fine. Again, like I said, most of the libraries have worked well for us, with the exception of things like that. But we have a few things occasionally that do not work very well. We're having some right now with UDP. I think we're overloading it because it is a very powerful little board and it can do a lot more. And we're trying to make it do a lot of stuff, but I'm not sure the W5100 chip can handle what we're throwing at it. Either that or some communication issues somewhere in there, and we're trying to figure all that kind of stuff out still. So it's still a work in progress. But, I mean, if you can get past the fact it takes a minute to boot, or almost a minute to boot, then it has everything you need on one board. The price is really good, so it's a decent board. And the other thing that I haven't shown you, let me see how I can maybe do this. Okay, here's one other thing. When you start your Ethernet, you can no longer specify your IP and your MAC address anymore. The MAC address is printed on the board. In fact, if I go over here, you can maybe see it right here. That's the MAC address right there. So it being Unix, it's going to automatically go DHCP. You can go into Unix and you can change that in Unix, but there's actually an easier way. Let me go see if I can get my code up here really quick. Do I have... Let me see what windows I have open with this. Actually, I might have my test program here that will show you exactly what we're doing. Yeah, right here. Let me go back over to the code. So this is our Galileo testing thing. So we've pretty much tested everything in this program. But what we can do is you can now access the Unix system right here. So what I'm saying is, hey system, I want to configure my Ethernet 0 to be 10.232.1.251 using this net mask, and please bring it up. And then I can also add my default route. So you can do anything through a system. In fact, you can call Python. Python is installed on it by default. I've seen people use different versions of Ruby on Rails in here as well, and they'll do things on the Unix side, and then just have the sketch reach out and touch it and ask questions, or have the sketch have it start doing something for it, things like that. So it's actually pretty neat that you can go down to that level. It was a little concerning at first whenever I was doing this right here, Ethernet begin MAC IP. You don't even got to do that at all. You don't got to Ethernet begin at all. It's already running. So you can completely skip the Ethernet begin part of it if you want, and it'll just work because the network parts comes up automatically right out of Unix, just like that. So that's some of the basics around this board. I mean, it's a pretty impressive little board. It's a little frustrating, some of the little drawbacks, but you got to remember that it's not really running an AVR chip. It's emulating what the AVR chip does in programming. And because the chip doesn't have all the same I/O, they're doing it through other I2C interfaces. So they've kind of hidden that from you. It looks and works basically the same way, and they've written the library behind it to go do it on a different chipset. So if you remember that, here's the other thing that really frustrates you if you're not careful. When you download this stuff, make sure you download it from Intel, because there's two different versions of the IDE, both from the same people, but they didn't change the version numbers. It's 153. There's an old 153 and a new 153. So if you go to Intel and you download the ones that are not the zipped versions, but the 7-zip versions, you should be okay. In fact, I have them both on my computer, and here's the other thing: the IDE is different. So let's come over here and we'll show you this, because this can really come back and make you wonder. So I started out with Arduino, which is the one that we all use if you're using any of the Arduinos, and then I downloaded the Arduino. I called it Arduino Galileo, and I kept upgrading the board, and it wouldn't boot from the SD card. And I started trying to figure out what was going on, and everybody says that people are uploading the wrong version. Download the newest version. That's still the same version number, 153, and then upgrade it, and it'll work. And they were right, it did. I downloaded 153, but it was the wrong one. This is 153, the wrong one. This is 153, the right one. So, as bizarre as that sounds, that is a versioning issue that somebody should just come out with 154 and say, here it is. Here's the newest version. That way you're sure you had the latest one. I don't know why they haven't done that yet. There is an Intel community. If you go to Intel, sorry, too many buttons. If you go to Intel, there is a whole community, a maker community. If you go to the communities, look for the maker part of the communities, and in there you'll have the Arduino stuff, and you can ask questions. It's not overly active. I've put some questions out there that I've never gotten a single answer to, but I'm sure it's going to change as this becomes more and more popular of a board. So if you're looking for something for a project that you don't need instant startup time, but you need like Ethernet and you need maybe SD card, well, you're going to have SD card if you want to boot back up on its own. You can use something like this, and it's actually not a bad price considering everything that comes with it. By the time you buy, the Uno, and then you buy the Ethernet shield, and it's skinny, it's small. I mean, if you look at it, it's the other thing I didn't mention on the bottom side, there's a PCI expansion, and it works with wireless because it runs Unix. There's lots and lots of wireless cards that will work with it just fine. You plug it in, Unix sees it and comes right up and will do DHCP right across it just by plugging it in. So if you're looking to use some kind of wireless solution, a really inexpensive PCI expansion card will work just fine in there. So that's another great option for this board as well. So overall, I mean, it's a great board, and I'm excited about it because it can do a lot more. It's a lot more powerful than the average Arduino. I mean, yes, it doesn't boot as fast, and we got to somehow tell somebody that it's still booting. Just be patient, which is a concern. Well, actually, we haven't even figured out how to do that yet, other than tell them it's going to take it almost a minute to come up. And you'll know when it comes up because the buttons do this, and that's how you can tell. Because you can't even have it do something in the beginning saying, hey, I'm still booting, because you don't have anything. So, I mean, I've looked at the option of basically having an LED on until I turn it off, using a NAND or something like that. I'm still looking at different options. So I could say when this light is on, it hasn't booted yet, and then I will turn off. I would basically make it go live, and which would turn the NAND off and turn the LED off, saying, hey, it's booted, that type of thing. So haven't quite figured out how to do that, other than I'm just putting notes in there saying it just takes a little while to boot. This is until it looks like this, it's still booting. But it makes you worry. Now I have the serial port I plug in, and if I'm ever worried about something, you can do that. So if you're going to do a lot of this, the serial cable is actually good, because if I struggled for days trying to get this SD card to work, and that's when I went and made the serial cable to say, what are you doing? And it was booting, kind of, but it would get stuck because something was wrong with the image. I needed to update the image. And that's when I updated the image and didn't change. And that's when I went through the whole rigmarole of finding out, hey, there's 2153s out there. So hopefully I've answered questions and saved you some time if you get one of these boards. Like I said, it's a pretty cool little board. There are some drawbacks to it, and I've mentioned those. But if you don't mind those drawbacks, I would say give it a shot because it's, like I said, very powerful. I love the fact that I can get to Unix and do things in Unix. I can do, expand it. I've actually done an application to control some cameras using Python. In Python, it was really easy to write the camera control. And I just have the Arduino sketch looking for the buttons to be pressed, and then it goes at the Python and says, hey, do this for me. Python goes and does it and comes back with a status. So very, very cool. And if you learn a little more about Unix, the ifconfig I showed you before, you can actually write a sketch for doing ifconfig, and it would pull back and tell you what it was using a sketch versus having to plug in the serial cable like that as well. Very cool stuff. So, and again, I showed you how to set the IP address if you want to. That's another option. That way you know where it is, because by default when it comes up, it's going to use DHCP if it can find it. And if it can't find DHCP, it won't do anything because it's configured to use DHCP only, unless you go in and actually change that. I think the problem with doing it is then you got to change it for everything you want to do. If you put it in your sketch, no matter where you go with your sketch, you're gonna change it. So, and also if you are just uploading your sketch without an SD card in there, then your sketch can still control the IP address versus, because if you go change the IP address without the SD card, it will not remember it. It won't even save it because that's all burned in. It's a lot smaller operating system. It doesn't have SSH, doesn't have a lot of things in it, doesn't have Python in it. That's what they use the SD card because it's such a small boot area when you're not using the SD card. All right, I think that's all I want to cover for this week. Let's see, it's been 33 minutes or so. Been rambling on. And hopefully you're watching this at 9 o'clock, and I'll be watching with you at 9 o'clock. And I'll be in the chat room to answer any kind of questions that you have. We do normally record a show at 9 p.m. on Monday nights. We've been... last couple weeks we've been doing better with that. And as November comes around and things start to kind of settle down and the new season starts for us, that'll all level out and kind of settle down there too. But come 9 o'clock on Monday nights and get in the chat room, chat with people. You can get our shows on any of the podcast directories, whether you're using an iPhone or an Android. Just go to your favorite, iTunes, obviously, for the iPhone, Dogcatcher, any of those other ones that you like on the Android. There's a bunch of them out there now. We should be pretty much everywhere. And if we're not, please let us know. We'll make sure that we get there. If you have a Roku, you can watch this on a Roku. You can watch on the big screen. All the stuff in the whole studio on the big screen. But any way you watch, whether it's on YouTube or on our website, whatever. And you can get our show notes from this show and all of our shows out at tech-zen.tv. And I can put down links to things I talked about. I don't really have any codes in it to show you because the Blink sketch I used was actually the Blink sketch from the Arduino examples. So, but I'll put links to all the different stuff for this board. I'll put links to the downloads for all the images and everything for the board and everything that I talked about tonight. It'll be out on the show notes sometime a little later this week, probably by Tuesday night or Wednesday morning. That's what we try to do. But definitely, thank you for coming in and watching. We do this, like I said, we do this show for you, and I appreciate all the feedback that we get. Oh yes, speaking of that, I'm sorry. I got some emails this week saying that some of the videos on YouTube had no sound, and you were absolutely correct. I don't know what happened. I recently upgraded my Adobe Premiere, and I don't know if I did something wrong in bringing it out, but I went and did it again, and it was fine. So that's all been fixed, though. All the stuff out on YouTube has been fixed, so there's audio everywhere. But I definitely appreciate you guys letting us know that. All right, everybody. We'll see you all next week. For show notes for this show, contacts, and more, go to the techzen.tv website where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the techzen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku.